Okay, we're now going to look at an actual data set in SPSS. So we're going to look at a data set called Fear of Statistics. But the first thing I want to do is just kind of run over SPSS with you. So if you go to the Mississippi State Information Technology Services software page with the list of all software available at Mississippi State University, if you go down, you will see that SPSS is one of the options available. So just where you install your other software, your Word, SPSS is one of the options. Note, you do not want SPSS Amos. That's something completely different and kind of way beyond the scope of this class. So SPSS, we have instruction installations for Windows and very detailed installation instructions for the Mac as well. As you've realized in this class, I know very little about Macs. So what you need to do is you need to press request software for student use. You want to download, you want to agree with the conditions, you want Windows, and you want version 28. Get software, it will download it, and then follow the installation instructions. Now, it's a little bit like Excel. Think of an Excel spreadsheet in that we have SPSS data files. So we can just basically click. We have this IHNO data set. So I'm just going to double click on this. And that will load in the data set into SPSS. Now, there's other, I'm going to talk a little bit about what's available, but you could also do File, Open, Data, and then click and then Open. That would be another way of doing it. And SPSS actually has, you can import different types of data. So you can import an Excel sheet, you can import a comma-separated list, and from all these other formats, which again, we're not going to worry about, but like SAS and Stata, are other kind of statistical packages. We have Lotus spreadsheets. We have a different database format. So we have all these different formats. So let's just have a look what we have here. Just notice that you have two different views. You have a data view and you have a variable view. The data looks a lot like it would look in Excel, where you have the column names and then the information in the columns. The variable view kind of defines the columns and the sort of information defined in the columns. So this is a data set. It's basically looking at students and it's looking at their performance on statistics and math exams related to kind of various attributes of the student and their general kind of phobia of statistics. So let's just look what variables we have. So we have gender. The subnumber is just the number of the person. We have gender, what gender they are, the major, the reason for taking a statistics class. And I know you guys all love statistics and marketing research, but I'm sure a lot of you might put program requirements in there. You need to take it to graduate. This is probably what I wouldn't be allowed to do in exams, is give some people easy exams, some people moderate, some people difficult, and some people impossible. But before we set the exams for these people, we have a condition. Remember, going back again to the previous week, this idea of control variables, we're controlling for the difficulty of the exam. And then, whether people drink coffee or not, how many cups of coffee they drink, their level of phobia on the scale of 1 to 10, previous maths classes, then how much they scored on the maths quiz, how much they scored on the stats quiz. And then we also have stuff like, people's base rate, heart rate, their heart rate before and after the exam. So we measure like the heart rate long before the exam, the heart rate immediately before and after the exam. And we also, I can't remember how this was measured, but we have some other measure of anxiety. Maybe it's something like we have with our Milo lab, maybe some sort of skin response, but we have some people are maybe more anxious than other people, but people's base anxiety, their anxiety before the exam and the anxiety after the exam. So this is all of our data. And you can see that this data, is mostly kind of numeric data. And when you get data from Qualtrics, even if you've given categorical names like unlikely, quite likely, somewhat likely, etc., etc., it will be stored as numbers. So what you have to do is you need to actually code the data. So quite often you will have numeric, and sometimes you'll get words that you have to code to numbers. Sometimes you get numbers that you need to code to words. And it can be a little bit tedious to kind of do all of this information. So I'll just show you the process of coding in SPSS. The idea is that every response should have a code. Obviously, if you have a free text column, then you can't code that column because that becomes ridiculous. And in most cases, this will be done automatically. Qualtrics would code your information, then you would load it into SPSS. What you might have to do is if you have numerical data, you might want to put in the names of the categories. So for examples here, we have gender, and we have 1 is female, 2 is male, and 3 is other. We have major, we have psychology, pre-med, biology, sociology, and economics. So these are all the majors taking it. The reason for taking the program requirement, personal interest, advisor recommendation. And the experimental condition, easy, moderate, difficult, and impossible. Now note to the right here, we have the measure, and this is the kind of the type of measure that we have. So if it's nominal, then we're intended to be a categorical variable. And if it's scale, then it's meant to be, a numeric continuous variable. So basically anything with categorical variables can actually be, this would actually be scale. The data set was wrong there. Anything with nominal, we can actually code. So let's just have a look at coffee. Let's click on this. And I think the value of 0 was, label yes, was drinks coffee. Add. And 0 would be does not drink coffee. Add. And then click OK. And now we have our coffee variable has been nicely coded. Okay, so the second thing we're going to think about is we're going to be thinking about how do we detect errors. Now, as I said in the previous video, quite often the software will look for this. We're not going to, we're not a computer science class. We're not going to go into methods of computerized error detection. But generally, if you have a set of data, just look over it for things that seem really odd or things that kind of seem a little bit strange. As I said, like if the example I gave in the previous video, somebody earning billions of dollars. Or you have 4 possible categories and somebody's answered a 5th category. Maybe there's been some error of transcription. So if anything looks out of place, then we can actually utilize, we can actually look through the data. Another way is to kind of tabulate the survey responses. And what that will do is we'll actually be able to kind of get a summary look at all the responses in the data, because it's actually quite difficult to go to SPSS and then look through each of these columns and look at every item. So we can get some sort of kind of categorical information, then this is going to be useful for us. Okay, so what we're going to do is we're going to kind of do 2 different types of error detection. We're first going to look at missing data, and then we're going to do this tabulation of the survey questions to look for missing data. And we're going to kind of go through a few specific examples. So the first thing we're going to do is we're going to look for missing data. Now, you look at this data set, you'll see some of these items have a dot. And this dot means that the data are missing. They weren't recorded. I guess this was an exam result, so somebody didn't turn up for the exam or was ill on the day of the exam. And, we've got quite a lot of these missing. We also have maybe 1 or 2 of the experimental conditions missing. I actually added those in just to give you an example of what missing data look like. Now, there's different types of missing data, and there's different ways of dealing with missing data. Again, a little bit beyond the class, but you can get kind of different patterns in missing data. So if you think of that, this was an example from a missing data book. I'll put this in the slides, but this is really a bit beyond this class. But say, for example, here we have the respondents of the rows and the columns of the questions. You can see here in this example, we only have missing data for one of the questions. So, you know, what do we do here? And here we have, you know, some of the data missed for one question, and then for the bottom respondents for both questions. Ideally, with missing data, we want a completely random pattern of missing data. That's less liable to bias our results. If we get, for example, you know, going back to my cell phone addiction problem, students are addicted to cell phones. There's a lot of missing data, and students who are not addicted to cell phones, and there's no missing data, then that's an issue because the missing data actually relates to the attributes of the data. But don't worry too much about this. Just be aware that there's different ways of dealing with missing data. For a start, we can actually remove every single row that has missing data. This is actually easier to do in Excel. We'll just sort it so the missing data is at the top, and we could just say, for example, you know, remove a row. So if we see missing data, we're going to cut it. Just cut the data. So that is going to be, you know, that's one way of doing it. Now, the disadvantage, if you have a random pattern of missing data, we're going to throw out a lot of observations. So if we say remove row 10, we've got lots and lots of useful data. We've got one missing piece of data. So to use a British expression, we're like throwing out the baby with the bathwater, in that we're throwing away a lot of good data just to get, you know, this one awkward missing data. Another way would be to actually replace each of these values with the mean value. So let's go to Math Quiz, and we're going to do Analyze Descriptive Statistics, and we're just going to put Descriptives, and let's just do Math Quiz. And then we're going to just click OK. We see the mean value for Math Quiz is 29.07. So what we could do is, let's go back in there, we'd actually replace each of these missing values with 29.7, 29.7, etc. And that, again, that's another way of getting rid of our missing data. The problem is with doing, this is called mean imputation, is it actually, it kind of biases the data set by reducing the variation in the data set. Now, nicely, SPSS has some methods for dealing with missing data. So let's just click missing value analysis. And let's just say we've got a quantitative variable, which is Math Quiz, and we want to estimate missing data. So we're going to click EM, which is a fancy type. It's basically creating distributions of the variables and then trying to predict where the missing data are. We're going to click EM, and we're going to click Save Completed Data, and we're going to call it IHNO complete, and we're going to click continue, and we're going to click OK. So we should have a new data set, which is IHNO complete, and you see we now have all these completed Math Quiz values. So we could actually paste this back in to our original data set. We're not going to do this for the moment, but this is a way of generating potentially values for what was previously missing data. Okay, so we just have a few little things I just want to finish off of other things you can do. If you want to go back for kind of, we've talked about coding. Yeah, one initial thing is that SPSS, a little bit like Excel, you can create new variables, you can rescale variables. So our Math Quiz is currently on a scale of 1 to 50. Now, say we wanted out, you know, just for consistency, like, you know, I do my exams out of 50, but I always scale it up for 100. Let's just say we want to Math Quiz 100. So we're going to click Transform, Compute Variable, and we're going to have a new variable, just call it target variable Math Quiz 100. And on the left, you have a little bit of a calculator. So we put Math Quiz, we select it, we click this little button, and we have Math Quiz there. I'm just going to type in ×2 for getting something from 0 to 50 to 0, 100 multiplied by 2. And I'm now going to click OK. So now we have a new variable calculated called MathQuiz100. And it's still, as we had missing data, it still has the original missing data. Now, the last thing we're going to do is we're going to go back and we're going to do this kind of one-way and two-way data tabulation. So let's just have a look at this idea of data tabulation. So with data tabulation, we've got one-way tabulation where we're just looking at a single variable. And the idea is we can look at, if there's any missing data, are there any categories we don't expect, any potential data quality issues. Cross-tabulation is just expanding to multiple variables. Now, realistically, we can't look at a lot of different variables in the table. It becomes too complicated. So when we do this, we'll be mostly looking at two-way tabulation, which is just literally looking across two different variables. And, we've already talked a little bit about how, we're looking at missing data, finding mistakes. And it also enables us to just get some initial results, some initial reportable results. So the instructions are in the slides, but I'm just going to kind of go through it now in SPSS. So we do analyze, descriptive statistics, frequencies, the variable reason, and, that was on because I tried it previously. So just select reason. We're just going to go with, we're not going to do, too much here, but let's just put things like, because, it's a categorical variable. So we'll just leave that. But we will do, let's just do a pie chart. So we'll click a pie chart here. And we're just going to click OK. So you can see here we have a summary. We have the program requirement, that's 40, which is 40%. We have personal interest, 28. Advisor recommendation, 30. And we also have, these are the ones I actually entered before, we have 2 pieces of missing information. So this again tells us how much missing information we have in a single column. And you see here this pie chart, we have 3 different reasons for taking the class. You can see program requirements the biggest, followed by advisor recommendation and personal interest. So we all want people to be enthusiastic about taking stats and research classes, but a lot of it is through program requirement and being told to by their advisor. Okay, so the next one we're going to do is we're now going to do a two-way tabulation. So let's just go to Analyze, Descriptive Statistics. Now we're going to do this one a little bit differently. We're going to click something called Crosstabs. This allows us to do cross tabulations. And what we're going to do is we're going to do major and reason. So it doesn't really matter which way the row and column are. So we've got major in row and reason in the column. And we're now going to click OK. And here again, we have this crosstab. We can show, okay, major biology and program requirement, there was 7. Major sociology and personal interest was 7. Psychology and program requirement is 20, etc., etc. And again, if there was no missing data in these columns, but if there's missing data, it would actually show up. So we get a vague idea of the distribution of the data. This is actually called a contingency table. If you recall back to your business stats, this is when you would do actually a chi-squared test. So this is going to be a two-way cross-tabulation or contingency table. Okay, so we've talked about, how to analyze categorical data. What happens if we have numeric data? Then we could calculate things like the mean. Going back 2 weeks ago, we can calculate if we have ratio scale data, we can calculate pretty much anything. We can calculate the mode, the median, the mean. We can also calculate these measures of how spread out the data is, the range and the standard deviation. So let's just do an example, and let's just have a look at the heart rate. See, this having a stats test is going to get your heart rate going. So let's just have a look at heart rate pre. So we're going to do analyze, descriptive statistics, and we're going to click descriptives, and we're going to do heart rate pre. Let's just go down. We have a few different options. So we're going to have the mean, the standard deviation, the minimum, and the maximum. We're not going to have any kind of advanced metrics. We'll just kick with the defaults. And we're going to click OK. And there we go. We say our heart rate, the lowest was 62, the maximum was 87. We have a mean of 73 and a standard deviation of 5. Now, that doesn't give us too much information. So this I want to show you something a little bit extra. So if we go to, let's just do it, analyze descriptive statistics, SPSS has a new feature called Explore. And what we're going to do is we're going to do same as before, heart rate pre. We could actually split it, so we could look at the heart rate separately for maybe males and females or for different genders, but let's just keep it simple at the moment. So statistics, descriptives will do the same as before, but let's have a plot. Let's have a histogram. We won't worry about normality plots, but let's just, yeah, we'll have a normality plot. And we're going to click OK. So here we have exactly the same piece of information, but we have the mean, we have a confidence interval for the mean, we have a median and variance. We also have some more advanced statistics like skewness. So this is skewed a little bit to the right. And then kurtosis is a measure of how peaked it is. We have a test of whether when it's the distribution is normal or not, as this is not my PhD class. I won't go into the Kolmogorov-Smirnov test. But this is a histogram, and you can see this data looks relatively like the bell shape you have in statistics. So there's no great kind of skew to this data. So you can see here that the average heart rate is around 75. And the normal QQ plot just tells you how, if all the points from this line, it's exactly a normal distribution. But that again is a little bit beyond the scope of this class. So, and again, here we have a box and whisper plot. So there's lots of different, this gives you a lot more advanced output. If you're doing your project, I wouldn't worry about QQ tests or something, but be able to show a little histogram of your data and explaining it, saying, hey, the data is not very skewed. You've got this almost as many to the left as to the right. You've got a average heart rate around 75. This is actually quite a nice plot for you to put in your project. Okay, and that's it. So what we've done is we've had an intro to SPSS. We've looked how to, the different types, the data view and the variable view. We've looked at coding in the variable view. And then we've looked at how, different ways of dealing with missing data, just removing the row, replacing with the mean. We also looked at advanced methods in SPSS. And then we looked at how to summarize the data. So how to summarize the categorical variables in one-way tables and two-way tables, and then how to get a little bit of descriptives for a continuous variable.